Next, we discuss about the open circuit and short circuit test on transformer in the students. So this is the open circuit diagram. So we have primary winding, secondary winding. So primary voltage 0 volt, 115 volt, 115 or 230 volt. So this side 0 volt, 115 volt, and secondary side is open 0 volt and 230 volt. So primary voltmeter, ammeter, and we have wattmeter, and we have auto transformer, or we call it as the variac. So since the primary voltage is 115 volt, they can put 115 volt, and secondary voltage is 230 volt, and it's 1 kVA transformer. 1 kVA transformer, you can find out the rated current of primary side and secondary side. Primary side will be 8.6, and secondary side will be 4.3 amps. That is 1000 by respective voltages. Since the primary voltage is 115, we can able to give as 150 volts on the voltmeter moving iron, and primary current will be 0 to 1 amp because it is open circuit. So the current will be minimum. So 1 amp is sufficient enough. So 150 volt per 1 amp, low LPF, low power factor. So to determine the fuse, so will be 40 percentage of rated current. So 4.4 into 8.6 will be almost 5 amps. So 5 amps is more sufficient to have the fuse. Come to the short circuit, we are starting on the load side. So we have variac, we have voltmeter, ammeter. So now we have to transpose the primary and secondary winding. So you have to short the less number of turns. This is step down. That is step up. This is step down. So the primary side will be high voltage side, and secondary side will be low voltage side. So it is safe to load on the secondary side. That is low voltage side. So primary will be 230 volt, secondary will be 115 volt. So the current will be reversed. Primary current will be 4.34, and secondary current will be 8.6. So the fuse setting will be, in case of load test, will be 120% rated current, 1.25 into 4.3 will be almost 10 amps. And primary ammeter and voltmeter on the side. So it will be 0 to 300 volt, 75 volt. Moving iron, because short circuit, so current will be 0 to 5 amps. Voltage will be minimum, current is maximum on short circuit. So it is 75 volt is sufficient, not 0 to 3 volt, 30 volt is not sufficient. So 75 volt, 5 amps, UPF will be there. So come to the tabulations, we have only one current, uh, open circuit voltage and short circuit current. So we have only one value to be tested. So open circuit voltage will be 115, and short circuit current will be 4.3. So if you keep that, you can find out the rest of the values. So note on the multiplication factor for open circuit and short circuit. So you can able to see on two wattmeters the multiplication factor for 150 volt 5 amps, 100 volt 10 amps. So 150 volt for 5 amps is B1. In both cases, we have multiplication factor as 1. 1. Now, while doing the open circuit test, you have to keep the open circuit voltage in the voltmeter, and doing short circuit test, we have to keep 4.34 and take only one corresponding reading. That is the corresponding short circuit voltage and open circuit current. After doing that, we go for the calculations. So let us go one by one. First, we can do calculations, and we can do connections for the open circuit. So this is the variac, single phase variac. We have primary side and secondary side, input and output side. So start giving connections. So from P to N, go to the input side of the variac, red to red and black to black. So from variac, other end it go to the voltmeter and ammeter. So this is P and this is N. So from P of output side of the variac, give across voltmeter, take two wires from the red terminal, output terminal of the variac, take two wires, one wire give to the voltmeter, another wire give to the ammeter. Since it's an alternating quantity, the transformer is working on AC signal only, so don't bother about the polarity. It's a common terminal. So from the positive terminal or the red terminal, give one into ammeter, another into voltmeter. So common terminal is given, and voltmeter, ammeter common terminal is given. Then from other end of the ammeter, give to wattmeter M, wattmeter M, and ML you have to short it. M and C you have to short it to wattmeter M, and you short M and C. Now from L terminal, you have to give to primary 0 volt of the transformer. The transformer winding is being swapped. So common terminal of 115 is being given. Then secondary is open circuit. Then wattmeter V you have to connect to N, and similarly this V also connect to N, and primary side P2 115 that also connect to N. So N has three: one out of voltmeter, one out of wattmeter, another one from the transformer. Give to N, another one from the transformer, another one from the voltage or V of the wattmeter, corresponding voltage, that is 75 volt. So now we can put upside down all the ammeters and meters so that it will be easy for us to note down the reading. So now you can once again check the connections if everything is made properly, and check whether all the connections are tight before you go for taking readings. Now experiment is ready. You can take reading. So turn on the supply, AC supply, and check the variac. Keep 115 volts. Only one reading, and note on the corresponding current. It comes around 0.4 and corresponding wattmeter reading. So open circuit current is zero point 0.5, and wattmeter reading is 12. Multiplication factor is 1. That's all. Bring back to original position, switch it off, and change the ammeter, voltmeter, and wattmeter for short circuit. This is UPF, and that will be LPF. So you need to lightly change the connections. It answer to be the same. Change the voltmeter first, then change the ammeter, then change the wattmeter. So you have to take 75 voltmeter, ammeter 5 amps ammeter, and wattmeter also is being changed. LPF and UPF wattmeter, and need to change the position of winding of primary and secondary. That is much more vital, because we need to short only on the low voltage side rather than the high voltage side to prevent any fault in the transformer. So after giving connections, now they are changing with the ammeter and voltmeter. Now ammeter is being changed. Now changing the wattmeter. M, MNC is connected. Is just swapping. Now you can put upside down all the required meters, ammeter voltmeter, so that is ready for taking reading. Swap the primary and secondary. So the primary will be on the high voltage and secondary will be the low voltage. Step down case. So open circuit will be step up, this will be step down. Now short the low voltage with a small wire. So now connections are ready. Turn on the supply and now keep the rated current. For short circuit, you have to keep the rated current 4.5. So only one value, so you have to keep as 4.5. So you can see. So 4.5 corresponding voltage, 15 corresponding wattmeter reading is being noted. Multiplication matter is 1, 15, 25, 25. That's all. So only one reading. So bring back to the positions and turn off. And then we can go to the calculations. So have some fractional load 25%, 50%, and 100 percentage, or one fourth. So you can able to have some fraction of load 0, one fourth, quarter, three fourth, and one. So output power you can able to calibrate. We have the fraction of load cos phi naught and sin phi naught. So cos phi naught will be open circuit power by V naught and I naught. Open circuit power will be the W naught from the open circuit voltage. This is short circuit voltage power. So V naught is open circuit power. So we know V naught, I naught, open circuit voltage and open circuit current IAC, I naught into cos phi naught. We call it as I mu, I naught into sin phi naught. So take reciprocal of cos phi. So phi is equal to cos inverse that value. Then you can take sin phi naught. Then R naught will be V naught by IW, and X reactance will be V naught by I mu, and RO2 will be VAC by IAC square. VAC is from the short circuit power. You can able to calculate it. Then you can find out the parameters RSC. Then impedances Z02 will be VAC by IAC, X02 will be Z02 whole square minus R02 whole square, take square root. That will give the reactances. Now to find out the losses of the transformer. So R1 will be R02 by K square, that's transformation ratio. The transformer X01 reactance will be X02 by K square. So the K is V2 by V1, is nothing but the transformation ratio. So V2 will be secondary voltage by primary voltage. So after finding out that, you can able to calculate the output power one by one. Then you can able to calculate the losses as open circuit W naught plus X square into WSC. So you know what is called X, fraction of load. We know what is called V naught. We know A square. We can able to calculate the losses, the input power, output power plus losses. Efficiency will be output by input. So it will be almost 97 percentage to 98 percentage. So after remaining all those things, you can able to find out the efficiency as well as regulations of the transformer. So the power factor you can keep it as some values 0. 0.2, 0. 0.4, 0. 0.6, 0.8, and 1. You can able to find out up regulation and down regulation. We call it as lag and lead regulation. So the relation of the percentage regulation of the transformer is going with the relation lag and lead. So for your different values of this one, you can able to find out the percentage regulation as I1 into R01 cos phi naught plus or minus X1 into cos sin phi naught divided by V1. So R01 is be calculated from the formula cos phi no we know. Then we can able to find out X naught. So if you have cos phi naught is zero. 0.2 or zero. 0.4 or zero. 0.6 or zero. 0.8, then you can able to find out sin phi naught. Take reciprocal of that. You can take sin phi naught. So plus for lagging power factor and minus for leading power factor. So for each and every value of power factor, you have to take two samples. So for cos phi, you have to put zero. 0.2, you have to take two values. Plus, if you put plus, it will be lagging. If you put minus, it will be leading. So substitute that and find out the two values. For lagging, you put on one column, and leading, you can put the other column. So after remaining each values percentage relation, you can able to draw the equivalent circuit to the transformer, respect to the primary, the result values. Then you can able to draw the model graph Percentage regulation versus output power, and percentage efficiency versus output power, as similar to the load tensor transformer. This is the graphs you can able to locate. So we have lagging and leading power factor. So based upon that, you're able to identify the losses of the transformer. So by this experiment, you are calibrating the losses in the transformer. You are determining the efficiency. We determining the efficiency so that losses can be minimized, and you are also finding out the regulation of the transformer. Thank you so much.